Every single one of us listening has that one story, right? That's something lodged deep in our minds. Maybe it's a fairy tale from when you were a kid, or that scene from a movie, or even a historical bit you just can't shake. Think about it for a second. Why can you perfectly recall the whole emotional journey of a film you saw ages ago, but maybe forget the three simple things your boss asked you to remember just this morning? Why do those stories manage to, well, glue themselves into our heads for years, sometimes decades, while a plain list of facts just disappears? Okay, so let's really dig into this. This deep dive is all about understanding the mechanics behind why narratives stick, neurologically, psychologically. Our mission here is to use the latest research to figure out that perfect storm, the mix of brain chemistry and structure that makes a story truly unforgettable.
It's really fascinating because it's not just random chance, is it? The brain actually seems to prioritize these narratives. It treats them like a highly organized personal experience. We've boiled down the research into really three big insights. First, stories change how your brain files things. Fundamentally, they become these detailed personal episodes. Second, emotion. Emotion acts like a massive chemical highlighter, telling your brain to save this experience for the long haul. And third, the actual structure of a story, the narrative itself, gives your brain a kind of cognitive template, makes it easier to file and, crucially, easier to pull back out later.
Right, that first point, filing a story like a personal event, that feels really important. It's not just general knowledge. Can you maybe break down for us the difference in how the brain sorts a story versus just a list of facts?
Absolutely. The key distinction here is between what we call semantic memory and episodic memory. Semantic memory is your database of facts. Knowing Paris is the capital of France or the chemical symbol for water, just raw data. Episodic memory, though, that's different. That's memory for specific events, experiences tied to a time and place. Like remembering the smell of your primary school canteen on the first day. It's personal. It has context. And the real breakthrough here is realizing that a well-told story, even if it's totally made up or happened centuries ago, kind of bypasses that fact-filing system. It gets encoded much more like an episode from your own life. You remember the sequence, the setting, the context, and importantly, how you felt when you heard or watched it. The story becomes, in effect, a vicarious mental episode.
Okay, wow. And this is where the hippocampus comes in, right? I find this part really interesting, this little Seahorse-shaped bit deep in the brain. It doesn't store the whole memory itself, does it? It's more like an integrator.
Exactly. It's the hub. It doesn't hold the data, but it's crucial for forming the memory, indexing it, and then retrieving all those different pieces, the sights, sounds, emotions, and weaving them back together into a coherent event.
So memory isn't like hitting play on a video recorder. It's more like rebuilding it each time.
Precisely. It's reconstructive.
Yeah.
And the hippocampus pulls these threads together from the visual cortex, auditory areas, the emotional centers, and it uses the coherence of the story itself as the blueprint for putting it all back together.
Can you tell us a bit more about that binding, how it actually links things together?
Sure. There was a really significant neuroscience study back in 2021 that showed just how powerful this narrative binding is. They found that when separate events, maybe things that happen far apart in time, could be understood as part of one single story, the hippocampus actively links them. It binds those details into one integrated narrative unit. And here's the kicker. The study showed that people could only recall previously unrelated memories if that narrative connection was mentally replayed. The story literally created the link.
So replaying the story strengthens the connection.
Yes, every time you recall the story, the hippocampus activates that integrated pattern, reinforcing the connections, making the memory stronger. That's why narrative makes memory so robust. It bundles everything together neatly.
That makes perfect sense. It explains why we can easily recount, say, the key moments of the Apollo 13 mission, or maybe the sequence of events on 9/11. They aren't just random facts and dates. They're told, understood, and shared as structured narratives. Cause and effect. The brain just naturally grabs onto that built-in organization.
Right. So if the structure is the scaffold, then emotion is it's the super glue. We really have to talk about emotion because feeling something is probably the single biggest predictor of whether a story will stick. All the psychological research points to this. Emotional experiences are remembered much, much better and often in greater detail than neutral ones. Think flashbulb memories.
Okay, so when a story hits us hard, makes us laugh out loud or cry, or gives us actual goosebumps, what's physically happening inside our heads to make that memory so sticky?
Well, when a strong emotion gets triggered, a key player is the amygdala. Think of it as the brain's sort of threat detector or emotional alarm system. It springs into action and sends signals to the hippocampus and other memory-related areas. It's essentially shouting, pay attention, this matters, save this.
An alarm bell for memory.
Pretty much. And this emotional arousal triggers a really important neurochemical surge. You get stress hormones like adrenaline, sure, but critically, you also get neurotransmitters like norepinephrine and, importantly, dopamine.
Ah, dopamine, the reward chemical.
Exactly. And because dopamine is so tightly linked to reward learning reinforcement, its release basically tells the brain, this event is valuable, invest resources in storing this long term. It chemically prioritizes that emotional moment in the memory queue, making it much easier to recall later.
So that satisfying plot twist, or the big emotional payoff at the end of a film, that feeling is literally your brain releasing dopamine, rewarding you for paying attention and anchoring the memory right there.
That's a great way to put it. It reinforces the learning, the experience.
But wait, if these emotional chemicals are so powerful, doesn't that sometimes warp the memory? Like, does the intensity of the feeling maybe distort the facts over time or color it? Where's the line there?
That's a really good question, and it's complex. The research suggests that while emotional arousal definitely boosts the vividness of the memory and our confidence in it, the core meaning, the gist of what happened, is usually pretty well preserved. But what's truly game-changing is realizing the scope of the brain's response during these emotional moments. It's not just one or two areas lighting up.
Okay.
Yeah, a major study from 2025, published in Nature Human Behavior, found something fascinating. Emotional arousal shifts the entire brain into a more integrated state.
Integrated state, what does that mean?
Think of the brain like a big orchestra, okay?
Yes.
You got the visual section, the auditory section, the part dealing with social thoughts, the emotional centers. Normally, they might be doing their own thing. Emotional arousal is like a conductor suddenly stepping onto the podium and getting everyone playing together, synchronized, coordinated. The whole brain lights up in concert. Wow. And this synchronized whole brain processing creates multiple pathways to store the memory. It makes the trace incredibly robust, much harder to forget. In fact, this level of integration was a really strong predictor in the study of which specific scenes participants would remember days later.
And that must be why empathy plays such a big role too, right? If a story really connects with your own life, your values, your struggles.
Absolutely. You're not just processing the story's emotion, you're linking it to your own emotional landscape. You encode the lesson, the personal relevance. Oxytocin, the bonding hormone, likely plays a role there too.
It becomes part of your story.
Precisely.
The classic example people always use is Bambi, isn't it?
It's a perfect one.
Most adults, even if they saw it decades ago, vividly recall the scene where the mother dies, that intense sadness, the shock. It's anchored by emotion. But ask them what Bambi had for breakfast that morning, or the color of Thumper's eyes. Probably gone. The brain selectively saves the emotionally charged, integrated moments.
Okay, so you've got this emotionally anchored memory. Now we need to think about encoding and retrieval. Encoding is that initial phase. Your attention is grabbed by the story, maybe helped by that emotional arousal, and that allows the brain to really record the information deeply. Focus is key. Frontal lobe activity.
Right, paying attention.
But retrieval is where the strengthening happens. When a story really hits you, what do? You think about it later, right? You mentally replay scenes, or you tell a friend about the amazing book you just read, or the movie plot.
Yeah, you recount it.
That recounting, that mental rehearsal, is retrieval practice. And every time you do it, you're actually strengthening the memory trace through a process called reconsolidation. It's almost like opening a file on your computer, maybe tweaking it slightly, and hitting save again. Each revisit reinforces it.
So, okay, we're encoding it deeply, we're retrieving and strengthening it, but what actually lasts?
Yeah.
Decades later? Is it the whole detailed movie playing in our head or something else? Memory is reconstructive, you said.
That's the crucial point. Long-term memory often isn't about perfect photographic recall. Your brain tends to let go of the precise perceptual details, the exact wording, the specific shade of blue, the background music. What it holds on to tightly is the gist, the conceptual meaning, the core message, the overall feeling. And that gist is usually saturated with the emotion you felt. That's what endures.
So meaning over minutia.
Largely, yes. And this was shown really clearly in another 2025 study. They compared how well people remembered stories that were rich in perceptual details, lots of sights and sounds described, versus stories rich in conceptual details.
Conceptual meaning, like the character's thoughts, feelings, motivations.
Exactly. Their reflections, their inner world, the why behind their actions.
And what did they find? Did the brain handle them differently?
It did. Both types of stories activated the hippocampus, that memory hub we talked about,
Okay.
but they connected to different networks. The perceptual stories linked more strongly to sensory areas of the brain, as you'd expect, but the conceptual, meaning-focused stories preferentially engage something called the default mode network, the DMN.
A DMN. Isn't that the network active when we're daydreaming or thinking about ourselves or the future?
That's the one. It's your brain's meaning-making network. It's involved in self-reflection, understanding others, thinking about past experiences and future possibilities.
So engaging the DMN makes the story feel more relevant to us, more personal.
That seems to be the implication. Participants in the study actually preferred the conceptual stories. They felt more confident remembering them, and they primarily recalled the gist, the emotional meaning. That connection to the self through the DMN makes the memory stickier.
But the best stories probably do both, right? Give us those vivid details and the deeper meaning.
Absolutely. The ideal story gives you both. Rich sensory details act like hooks for your perception, while the strong conceptual meaning hooks into your values and sense of self. Multiple anchors.
And that taps into multisensory encoding too.
Yeah.
A good storyteller doesn't just tell you things, they make you feel them, almost experience them.
Right. If a story describes a delicious meal really well, your olfactory and gustatory smell and taste regions might activate slightly. An intense chase scene, your motor cortex might fire up a bit as you mentally simulate the running.
So our brains are running a mini simulation.
In a way, yes. We're not just passive listeners or readers. We're actively constructing the experience in our minds, which makes it feel much more like something that actually happened to us.
That explains the Titanic example perfectly. Years on, one person vividly remembers the sight of the ship breaking.
Perceptual detail.
Another remembers the sound of the band playing on.
Auditory detail.
And someone else remembers the feeling, the idea of that final goodbye between Jack and Rose.
Conceptual and emotional detail. Exactly. The story gets encoded on all these different levels using multiple brain systems, which is why it lasts. So we've got the emotional glue, the episodic filing via the hippocampus. But none of this works super efficiently if the information is just a jumbled mess. The way information is presented, its structure is hugely important. A narrative structure, a story, fundamentally reduces the cognitive load.
How so?
Because it organizes the information for you. It provides a beginning, middle, end. It establishes cause and effect. Your brain doesn't have to work as hard to make sense of it initially.
It's like getting information that's already been neatly filed. It fits into a pre-existing mental map.
That's a great analogy. Educational neuroscience research talks about this. Familiar narrative structures, the classic 3-act structure in movies, or the simple setup problem resolution arc in fairy tales, they form a ready-made cognitive template.
Like a filing cabinet with labeled folders already there.
Pretty much. Your brain knows these patterns. When new information comes in packaged as a story, it slots right into that familiar organizational system. Much easier than trying to remember disconnected facts.
And that structure also keeps us hooked, doesn't it? Stories make us want to know what happens next.
Yes. They tap into our basic instinct to predict. Will the hero win? Will the couple get together? We're constantly running mental models anticipating the outcome.
And when our prediction is right, or even when we're surprised in a satisfying way.
Dopamine again. That successful prediction or the satisfying resolution gives you a little reward hit, which further reinforces the memory of the story's pattern. You're actively engaged in processing it, not just passively receiving.
So that dopamine reinforces a causal structure too. This happened because of that.
Precisely. Understanding the why is critical. We remember stories much better when we grasp the causal links between events and how they lead to a resolution, not just a list of what happened. Those narrative connections, this led to that, which caused this act as logical hooks for memory retrieval. If a story doesn't make sense, if it lacks that coherence, the brain struggles to find a pathway back to the information.
This has such a clear, practical takeaway for everyone listening, doesn't it?
Yeah.
If you need to communicate something important, or even just remember complex information yourself, stop trying to memorize bullet points or raw data.
Frame it as a story.
Exactly. Think about teachers. They don't just list dates about Alexander Graham Bell. They tell the story, the struggle, the experiments, that famous Mr. Watson, come here moment.
Because hooking information onto that narrative template makes it vastly more durable. The brain is just fundamentally wired to process, prioritize, and preserve information presented that way. So if we pull it all together, that perfect storm for an unforgettable story really involves these 3 key elements working in synergy. First, Stories provide that essential structure for episodic encoding, leveraging the hippocampus. Second, they get chemically tagged as important through emotional engagement involving the amygdala and that crucial dopamine reinforcement. And third, they engage multiple brain networks in that synchronized, integrated way, especially connecting to the default mode network for extracting personal meaning and relevance.
It's the structure, the emotion, and the whole brain integration.
It's the core of it.
So the practical advice for you listening is pretty straightforward. Next time you're faced with complex information you need to remember for work, for study, whatever, resist the urge to just make a list. Try turning it into a narrative, even a simple one. Give it a clear beginning, a challenge or a problem, a resolution. Add an emotional hook if you can. Make it personally relevant somehow.
And maybe we can leave you with this final thought to mull over. Why are we so hardwired to remember stories in the first place? It's likely because stories have always been absolutely crucial for human survival, for social bonding, for sharing vital knowledge across generations, for learning from others' experiences without having to go through the danger ourselves. The stories that resonate most deeply, the ones that truly stick, often become woven into our own personal narrative. They shape our values, our understanding of the world, even our sense of resilience. It really is a beautiful synergy of heart and mind, isn't it? The heart feels the emotion, the mind structures the experience and remembers the meaning, and an unforgettable story is born.